Let's talk about resistor color codes. The value of a resistor in ohms is not printed as a number on the resistor. No, it is coded as 3 or 4 color bands that are read as follows. Band 1, it's a brown, that's a 1. Band 2, it's a green, it's 5. Band 3, it's red, it's a 2. Band 4, it's gold, signifies plus or minus 5%. But exactly what is what we're doing here? What is the code that will allow us to read those bands? Well, the code is based on the rainbow. You see, we go low to high, from low energy red all the way to high energy violet. The color purple, it's too easy to be confused with blue or with violet depending on how old the resistor is, so we are not going to use purple. We use brighter than violet is white, is the highest of them all, and something slightly less than white, that is gray. We are short by 2 bands, so we can have numbers from 0 all the way to 9. So what do we add? On the low end, we add brown, and even lower than that, black. So we begin with black being 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, 6 is blue, violet is 7, gray is 8, and 9 is white. That is a color code. Now, how do we apply those color code numbers to the reading of a resistor? Like this. If the color bands are either the first or the second bands, well, they signify the numbers that we've seen. Black 0, brown 1, etc., etc., etc. But if it's the third band, the color indicates the number of zeros that we have to add to the right of the first 2 digits. The fourth band is the tolerance band. It indicates how accurate the value provided truly is. If it's a gold, the value provided is plus or minus 5% accurate. If it's silver, plus or minus 10%. If there is no tolerance band, that is, if there is no fourth band, and that is a plus or minus 20% resistor. If you want to have a very accurate resistor, then you look for either a brown fourth band, plus or minus 1, or a red, plus or minus 2%. If you really want something ultra accurate and expensive, go for the fourth band being a violet, which is plus or minus 0.01%. Let's go and read what is the value of this resistor now that we have the color code. 4 bands, eh? So we go from the left to the right being the gold one, the tolerance one. The first band is brown. We know brown is 1. The second band is green. Green is 5. So we have 2 digits, 1 and 5. What else? The third band is a red, a number 2. But a number 2 on the third band indicates the number of zeros that we need to attach to the already present 2 digits. That tells us that the value of that resistor is 1500 ohms. The fourth band, gold, tells us that the value of 1500 ohms could be anywhere around that plus or minus 5%. That is, the true value could be anywhere between 1,425 and 1,575 ohms. But what happens if we need the exact value of that resistor? Well, in that case, we use an ohm meter. And for that, I better show you the video on using our multimeter as an ohm meter. Now the multimeter as an ohm meter. First, with the instrument off, check that the red probe is up here, where the Greek letter omega gives away its use. Second, turn the multimeter on and press the selection button with the omega on it. Now, apply the black probe to one terminal of the resistor that you want to measure and the red probe to the other terminal. The display will read the actual resistance of that component in ohms, in kilo ohms, in milliohms. Simple, huh? One comment, please do not press the probes to the resistor terminals with your bare fingers. If you do this, which would be alright and give you a decent value for high resistances, what you would be measuring instead is the resistance of the parallel of your own body between your fingers and the resistor that you are investigating. That measure would depend on the pressure you apply, how dry, how clean, how callous your hands are. Too many variables if you ask me. Just plug the resistor to the breadboard between two unused multiclips, and then the ohmmeter probes to the same two multiclips, and you get a more accurate and fair reading.